The main purpose of this presentation is to empower the consumer to achieve the highest impact from their energy efficiency efforts. When we are at the consumer, we are faced with challenges. The first one is that there is often a lack of a yardstick or metric, or even set targets such as best practice to guide the consumer. Secondly, we have a limitation due to our narrow comprehension of what really constitutes energy waste. For example, very few of us will look at a leaking pipe and interpret that or recognize it as wasted energy. But one way to see the bigger picture is to zoom out and then allow yourself to fill in the gaps. For example, the national power utility will have supplied that power to drive water through the leaking pipe, and that will be picked up. One of the best performance indices at macro, at national, regional level is the energy intensity of the economy. It aggregates all the energy consumed for every GDP of growth realized in the economy. So once we have seen the gaps, we can now zoom back to the consumer end and make a much more improved assessment. For example, now when we recognize this packet of wheat flour that has poured on the ground, we'll immediately realize that it is wasted energy. Let's take the example of a bakery. We will assume that this bakery makes only bread, and everything else is an overhead. So when we look at the energy consumed, we will not just consider the energy that was consumed in the kitchen. We will aggregate all the energy that is supplied by the utility to the company, regardless of whether some of that energy was used to make coffee or was used to drive a vacuum cleaner. All those overheads are normally heaped onto the bread. We also have realized that the other materials such as water, wheat flour, and so on also have energy implications, and therefore we'll include them on the overhead, on the overheads or footprint of the bread, per loaf of bread that is output. So we'll draw a boundary around the bakery and treat the bakery as a black box where the inputs are energy and water and other materials, and the output is bread and of course waste. So our metric, total metric, will be the summation of water, energy, and other materials used for every 500-gram loaf of bread. That will be its footprint. This is a novel proposition. Such a methodology has previously been used in the context of energy alone, like electricity and gas, but not with the inclusion of materials. So some study data will be required, but in principle the methodology is straightforward. The aim is to minimize inputs without compromising the quality of the bread. The regulator may set targets and best practice, and the consumer will be encouraged to use their own creative ways to achieve this. This is a Japanese model where the authority, the government, creates regulations and guidelines but does not micromanage the way the consumer achieves the objective. Depending on the culture of the consumer, there could be an open source platform opened whereby consumers share their different experiences and innovative ideas. One of the best tools is material and energy flow analysis. This is an old tool in principle, but has not been adequately exploited, and it can be applied at different levels: company level, entire economy, households, and regions. Another area where waste will happen beyond the control of the bakery is at the consumer end, in terms of how much bread is wasted. Another context of waste is more subtle. It's more of overconsumption. This lady's wardrobe contains tens of pairs of shoes, and one assumes that if I came and took away a few, she probably wouldn't know. But her consumption drives the manufacturer to consume more energy to be able to meet this culture of consumption. Globally, the most systemic impediment to energy efficiency is the concept of the stock exchange. The stock exchange rewards a company for volumes of consumption without concern for the quality. For example, the bread consumer's waste is a benefit if, when the consumer wastes more bread, the bakery is forced to make more bread and sell more bread, and they make more money. Investors will be interested in such a bakery because it's a high performing, even though in reality such activity does not result in economic development. A note on material and energy flow analysis being defined as a systematic assessment of flows and stocks of materials within a system defined by space and time. We'll prepare a more advanced presentation for those who will be interested in using this as a tool for their energy efficiency, especially in industry. But in the meantime, you might find these references useful for further reading. This is the end of part 4. Part 5 will cover the subject of energy sustainability. Thank you.